Hi friends, welcome back to our YouTube channel. Today we have to discuss about address sequencing in Computer Organization and Architecture course. First of all, what is address sequencing? Address sequencing is defined as the sequence of addresses of micro instructions which are to be read from the control memory. This definition can be illustrated with this diagram. This is the control memory diagram. In that control memory, we have to store the microprogram. A microprogram is nothing but sequence of micro instructions. The first micro instruction address is 100. Last micro instruction address is 202. Total 103 micro instructions are there in the microprogram. In which order we have to read these micro instruction addresses from the control memory? That is in a sequential manner. The order in which we have to read the addresses of the micro instructions from the control memory in a sequential manner is nothing but address sequencing. That means once the current micro instruction is executing, then the control determines the address of the next micro instruction in the sequence. That is called as address sequencing. The address sequencing can be done in 4 ways. First way is incrementing the content of the control address register by 1. The second way is conditional branch or unconditional branch depending on the status bit conditions. The third way is mapping logic or a mapping process that transform the instruction code bits to an address for the control memory. And fourth one is a facility for subroutine call and return. So in these 4 ways we have to achieve the address sequencing capability. Okay, now we are considering the first one. Increment the content of the control address register by 1. In this way, we have to use the incrementer. That incrementer increments the content of the control address register by 1 to select the address of the next micro instruction. I am explaining this way through this example. Initially, control address register is loaded with the address of the first micro instruction. What is the address of the first micro instruction? That is 100. While executing the instruction that is specified at micro instruction 100, the control must determine the address of the next micro instruction in sequence. For that purpose, we have to use the incrementer. Incrementer increments the content of the control address register by 1. Here the content of the control address register is 100, that is incremented by 1. 100 plus 1, that is 101. So 101 is the next micro instruction address. In this way, so we have to achieve the address of the next micro instruction. Next, second way is, now the 101 is loaded into the control address register. So here the content of the control address register is 100. That can be incremented by 1 by using the incrementer. Then what is the next micro instruction address? That is 101. That is loaded into the control address register through the multiplexer. Okay. Now we can go for the second way. Unconditional branch or a conditional branch depending on the status bit conditions. Okay. First we can go for the unconditional branch. Unconditional branch is nothing but without checking any condition, we are transferring the program control from one location to another location in the microprogram. That branch address is specified within the instruction. Okay, so here this is the branch address. This branch address is nothing but unconditional branch address. That address is specified in the address part of the micro instruction. Now we are executing the 100th micro instruction. So in that instruction, unconditional branch instruction, that is jump 102 is there. JMP is nothing but jump. This is the branch address. That branch address is 102. Okay. Control address register stores the address of the current micro instruction. So current micro instruction address is 100. In that current micro instruction, the instruction is JMP and branch address is 102. Whenever we are executing this instruction, the program control immediately transfer from the current micro instruction to the address specified within the instruction. So that means the program control can immediately transfers the program control from the current micro instruction address 100 to the address specified within the jump instruction, that is 102. Now CAR pointing to 102. Okay, so here the branch address is 102 and branch instruction is JMP. It is available at the micro instruction address 100. Whenever we are executing this instruction, the program control can immediately transfer from this current micro instruction to 102 micro instruction. That can be loaded into the control address register through the multiplexer. This is called as unconditional branch. Without checking any condition, we are transferring the program control from the currently executing instruction to the address specified within the instruction. That means transferring the program control from address 100 to 102. 102 is the next micro instruction address. That address is loaded into the control address register through the multiplexer. This is called as unconditional branch. Next, whereas in the case of conditional branch, here we have to check the condition first. Whenever we are checking the condition, if its value is 1 or 0. If its value is 1, the particular branch address is loaded into the control address register. If its value is 0, then simply we have to increment the content of the control address register by 1. In this case, we have to check various status bit conditions. So first one is 0 flag, second one is sign flag, third one is carry flag. Okay, we have to check the status bit conditions. First, we have to select a status bit. Then we have to check the status bit condition by using the branch logic. Then we have to know the value of the status bit condition, whether it contains either 0 or 1. If its value is 1, then the corresponding branch address is loaded into the control register through the multiplexer. If its value is 0, simply we have to increment the content of the control address register by 1. Here 0 flag is used for checking whether the accumulator contains the 0 value or not. If the accumulator contains the 0 value, then it can be set as 1. Whenever this status bit value can be set as 1, then the corresponding branch address is loaded into the control address register. If the accumulator contains the value 0, then Z value can be set as 0. At that time, simply we have to increment the content of the control register by 1 to get the next micro instruction address. Next, in the case of sign flag, if the most significant bit value is 1, then it can be set as 1. Otherwise, it can be set as 0. Whenever the sign bit value can be set as 1, the corresponding branch address is loaded into the control address register by using the multiplexer. Next, this is the carry flag. If the AND around carry is generated, then it can be set as value 1. Otherwise, it can be set as value 0. Whenever the carry bit value can be set as 1, then the corresponding branch address is loaded into the control address register. Otherwise, simply we have to increment the content of the control address register by 1. In this way, we have to select the next micro instruction address by using the status bit conditions. Okay, so here first we have to select a specific status bit that can be tested by using the branch logic. After testing, it contains either 0 value or 1 value. If the status bit can be set as 1, then the corresponding branch address specified in the instruction is loaded into the control address register through the multiplexer. If the status bit value can be set as 0, then simply we have to increment the content of the control address register by 1. In this way, we have to select the next micro instruction address. This is called as conditional branch. In the unconditional branch, without checking any condition, simply we are transferring the program control from currently micro instruction address to the address specified within the branch instruction. In the case of conditional branch, we have to select a specific status bit from the control memory. We have to check the status of that status bit, whether it contains a 0 value or 1 value. If its value is 1, then its associated branch address specified within the micro instruction is loaded into the control address register. If its value can be set as 0, simply we have to increment the address of the content of the control address register by 1. That branch address is loaded into the control address register through the multiplexer. In this way, the second way is performed. Next, third way is mapping logic. So generally, a simple computer instruction consists of 16 bits. That 16-bit address can be divided into two fields. First field called as address field. So 0 to 11, that is 12 bits can be allocated for address. Next, 12 to 15 bits can be allocated for opcode. Okay, this opcode defines what is the operation to be performed. By using the 4 opcode bits, we have to perform 16 operations. So 4 bits can be sent to the decoder. It can produce 2 power 4, that is 16 outputs. Each and every output can perform a separate operation. Now, for every 4-bit operation code bits, there exists a micro instruction address in the control memory. Okay, so that means the 4-bit operation code can be converted into 7-bit address for control memory. That conversion process is called as mapping. Mapping is nothing but conversion of 4-bit opcode into 7-bit address for control memory. How mapping can be done? Placing a 0 in the most significant bit of the micro instruction address. Okay, here we have to place a 0 at the most significant bit of the micro instruction address. Next 4 bits as it is can be transferred to the micro instruction address. That is a 4-bit opcode can directly transfer to the micro instruction address. The 2 least significant bits of the control address register can be cleared. Okay, so here we are getting these 2 zeros, and this is the most significant 0, and these are the 4 opcode bits. So total 7-bit micro instruction address. This is the normal instruction address format that consists of 16 bits. Here we have to apply the mapping logic, placing a 0 at the most significant position of the micro instruction address and clearing 2 least significant bits of the control address register. The remaining 4 opcode bits can be directly transferred to the micro instruction address. Then we are getting the 7-bit micro instruction address. This 7-bit micro instruction address is directly loaded into the control address register through the mapping logic. Here instruction code is nothing but opcode that is present in the simple instruction format. That 4-bit opcode can be converted into 7-bit micro instruction address for control memory by using the mapping logic. That external address that external address is nothing but 7-bit micro instruction address is loaded into the control address register by using the multiplexer. Next, in this way mapping logic can be performed. And fourth one is subroutine call and return. So subroutines are nothing but simple programs. These programs are used for performing a particular task. Subroutines can be called anywhere in the main body of the microprogram. Subroutines are nothing but simple functions in the C program. Okay, whenever a subroutine can be called in the main program, the program control can immediately transfer from calling function to called function. Once all the statements within the called function are executed, then we have to return the control from the called function to calling function in the main program. So this can be done in the C programming. Same way, function is nothing but subroutine. Okay, suppose we are taking one subroutine. That subroutine can be called by using a call instruction, call 200. Call 200. Whenever we are executing that instruction 102, 102 is present in the control address register. While executing the current micro instruction that is present at 102, what is the next micro instruction that are to be executed? Simply we have to increment the content of the control address register by 1. So 102 plus 1, that is equal to 103. So this 103 is called as a return address. That return address is stored in a register called as subroutine register. So SBR is nothing but subroutine register. This subroutine register contains the return address from the subroutine. That means simply we have to return from the subroutine to main program. Okay. Now, whenever we are executing the instruction at 102, so the instruction is call instruction. So here call 200. The control can immediately transfer from 102 to 200. Okay, 200 is the first micro instruction address in the subroutine. So here subroutine is starting from 200 and ending with 202. The main program starting from 100 and ending with 199. Whenever we are calling a subroutine at 102 address, the program control can immediately transfer from 102 address to 200 address. At that time, the subroutine register can store the return address. The return address is nothing but 102 plus 1. While executing 102 instruction, what is the next micro instruction address? 102 plus 1, that is nothing but 103. Subroutine register contains the 103. After that, the control immediately transfer from 102 to 200. After executing all the statements within the subroutine from 200 to 202, we have to return from the subroutine to main program. Okay, for that purpose, we require the return address. that return address is stored in the subroutine register. That address is loaded into the control address register. Okay, so here the control address register contains the 102 address. While executing the subroutine call at microinstruction 102, the program control immediately transfer from 102 instruction to the 200 instruction. 200 is the starting instruction address of the subroutine. At that time, we have to store the return address. That return address is nothing but content of the control address register by 1. For that purpose, we have to send the content of the control address register 102, that is incremented by 1, that is 103. This 103 is stored in the subroutine register. This address is loaded into the control address register by using the multiplexer. Okay, so in this way, how subroutine call and return can be performed. SPR is a subroutine register that contains the return address. That return address is used for transferring the program control from the subroutine to the main program. Okay, so now observe the multiplexer. This multiplexer can take 4 inputs. Okay, one input taken from the branch address, another input taken from the mapping logic, another input taken from the return address from the subroutine register, another input coming from the incrementing of the control address register by 1. So among that 4 branch addresses, we have to select only one address. For that purpose, we require a multiplexer. Its size is 4 by 1. Okay, 4 inputs and 1 output. By using that 4 by 1 multiplexer, we have to select one branch address. Among these 4 branch addresses, whatever the branch address that is selected, that can be loaded into the control address register. Okay, here the multiplexer output value is always equal to 1. Whenever the multiplexer output value is equal to 1, then among that 4 alternatives, one alternative is selected. That selected branch address is loaded into the control address register. Suppose if the multiplexer output value is 0, then we are not selecting any branch address among the 4 alternatives. Simply we have to increment the content of the control address register by 1. Okay, so in this way, address sequencing can be done in 4 ways. Okay, here the control address register can be operated by applying the clock input. Whenever the clock input is applied, whatever the branch address that is selected, that branch address is loaded into the control address register whenever the multiplexer output value is 1. Otherwise, simply we have to increment the content of the control address register by 1 to select the next micro instruction address. In this way, we have to select the next micro instruction address while executing the current micro instruction in the sequence. That can be called as address sequencing. Okay, I hope all of you understanding this concept. If you clearly understanding these 4 ways, please watch the video that is available in the comment section. In that video, I am clearly explaining these 4 ways. Okay, that video is lengthy, but understanding purpose, I am clearly explaining these 4 ways. That video is available in the comment box. I hope all of you understanding this video. If you really understanding this video, please share this video to your friends and classmates. If you really understanding this video, please subscribe my YouTube channel, Divvela Srinivasa. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Thank you one and all for watching this video.